Okay, what I wanted to do today was continue working on some limit problems. In particular, we're looking at situations where we have the limit at infinity. So we have this problem on the board. We have the limit as x approaches infinity of 3x cubed minus 7x squared plus 5. And what I'm going to do to evaluate this, I'm going to just take the term with the highest power here, which is x cubed, and we're just going to factor out an x cubed and see what we have. So we have x cubed times 3, and then on this term, this is going to become 7 over x, and this is going to be 5 over x cubed. Now, the reason we do it this way is just notice if you plug infinity in here, 7 over infinity, this term's going to 0. And then here, plugging infinity in, 5 over infinity cubed, this term's also going to 0. Now, you plug in infinity into the x cubed, that's infinity times 3, so clearly this thing is going to infinity. And the thing I want to notice about this technique, when you factor out the highest power, it really doesn't matter really what our polynomial is, right? All these terms with lesser degree, it's always going to be the situation like any x squared term is going to 0, or any constant term. Anything of lower degree is going to 0. So this is, regardless of what polynomial we choose, all these other terms are going to 0. And then even this 3 doesn't really matter. The only thing that could change this is if this was negative. So it's really just a matter if this is positive or negative. If this was a negative 3, then we'd be going to negative infinity. So what this allows us to do is we actually don't have to factor this every time. What we can do is we can just kind of look at the first term. We can ignore all this stuff, evaluate this at infinity, and we can just see that this is infinity. So you can kind of just do this on site. Next, we have something here kind of similar, except we have the polynomial in the denominator. Now we're looking for the limit as x approaches infinity of 2 over x squared plus x minus 9. Now, we can use that same trick we did in the previous problem. We can just focus on this x squared term. We don't have to worry about this because it's not going to matter. And then clearly you plug in infinity in here, infinity squared. This is going to be 2 over infinity, right? But really what's going to happen when we have infinity in the denominator, this is going to just be 0. So we can evaluate this one really quick. Whenever we have some finite number in the numerator and infinity in the denominator, that's going to go to 0. Okay, now this one we can do really quick based on what I just said a second ago, which is we're going to plug this in. We have infinity in the denominator, 1 over infinity. This is clearly going to 0, so not much to do there. But what I really want to do here, let's get rid of this. Instead of evaluating this at infinity, what happens if we evaluate this at 0? So over here we have a very rough graph of 1 over x, and kind of like we saw in the other one, we were way out here at infinity, off the board of course, this thing's going off to 0. But now we want to look at this, we want to look at this limit as x approaches 0. Now at 0, it's a little weird because we get this vertical asymptote situation going on where it really depends what side we look at it. Well, like I've said in the previous video, to evaluate the limit, what we really need to do is look at it from two sides. We need to look at the right-handed limit as x approaches 0 plus, and then we also need to look at the left-handed limit as x approaches 0 minus. And so in this case, it's a little hard to see. So if I look at 0 plus, like 0 plus is going to be something like 0.001, some really small number in here. Well, we can't really tell from this graph what's happening, but you can kind of see this is going way off to infinity. And if you were to plug in, you just notice if you plug in a really small number into the denominator here, if you put in like for example, if you just put in 0.01 here, you'd get 100. So in other words, when you put a really, really small number in here, this thing is going off to positive infinity. Then really similar on the left side, we're going to be looking right on the left side here at like a really small negative numbers, really close to 0. And if we do that, we kind of see at some point it's going to be way down here. And what you notice, if you put really small negative numbers in here for x, you're going to start getting really huge negative numbers. And it turns out this is actually going to be going to negative infinity. And so as it turns out, the right-handed limit and the left-handed limit are not the same at all. Infinity is not minus infinity. So we've got no agreement between our right-hand and left-hand limits. So we have to say that this limit as x approaches 0 does not exist. Okay, now here I've made kind of an insignificant change, right? Instead of doing 1 over x, we're looking at 1 over x squared, but you'll notice our graph looks really different on the left side particularly. On the right side, it's actually pretty much the same kind of thing, or it looks the same. And what we're gonna do, we wanna do the same thing. We're gonna wanna look at this from both sides. So let's look at this to evaluate. We're gonna look at x as it approaches, we wanna see x as it approaches 0 plus of 1 over x squared. And we also wanna check the limit as x approaches 0 minus of 1 over x squared. And we'll do this kind of quick, but from the right side, we can clearly see that this is going off to infinity. If we put, this is really the same kind of situation we saw before. We put a really small number in here. This is going to infinity. Now, if we put in a really small negative side and we check from the left side, well, what's going to happen now that we're squared here, instead of going off to minus infinity, so everything's going to be positive, and this is also going to infinity. And so because we have this agreement between the right-hand and left-hand limit, this limit is going to infinity. Okay, next, this is actually a really similar problem, just kind of a minor variation of what we just did with 1 over x. You'll notice if we just plug a 4 in here, well, then we have 9 over 0, and so that's going to be a problem. But what we want to do is we want to evaluate this from both sides. So we want to look at this at x approaching 4 plus, and we're also going to want to look at this at when x approaches 4 minus from the left side. Now, we won't do a graph for this one. Now, if you just picture numbers that are just a little bit bigger than 4, if you picture like 4.001, you plug that in, you're going to have a really small positive number. You have a really small positive number in the denominator. This thing is going to be just going off to infinity. And then we do the same kind of check from the left-hand side, looking at numbers that are just a little bit less than 4, like 3.9999 or whatever. You plug that in here, you're going to have a really small negative number. When you picture plugging in a really small negative number, this is actually going to be going to negative infinity. So now again, this is a situation where the right-hand limit and left-hand limit are not the same, so we have to say that this limit does not exist. Okay, one last problem. You see where I'm going with this, I think. So this again, we plug a 4 in here, we're dividing by 0. So we'll check it from both sides. And this is really similar to our 1 over x squared case, but I just want to spell it all the way out. So we'll look at this from the right side. We'll look at this as x approaches 4 plus. And we're also, of course, going to look at this from the left side. We'll look at this as x approaches 4 minus. Evaluate this from the right side, and you're going to have a really small number in the denominator. So this piece is clearly going to infinity. And then here, doing what we did before, when we put something in from the left-hand side, initially this is going to be a really small negative number, but we square it and we get a really small positive number. So it's really the same thing as what we have here. So this is going to infinity. Our left-hand and right-hand limit, the same thing. So we can say that this limit as x approaches 4 is just going to infinity. Okay, that's it. So we'll stop it there. More limit problems coming soon. Thanks for watching. Have a great day.